Okay, as John said, and thank you very much for the introduction, my name's David Goody. This session, actually the key thing behind this, we had some great sessions this morning. As I said, really loved sort of the stuff from Trussell Trust, the stuff about the sort of the movement stuff that was going on. The thing I sometimes find coming away from these conferences, you see brilliant stuff, and then you come back to your desk and you think, yeah, but that's what other people do. That's not what I'm able to do. So the whole thing I keep coming back to in this session is about how you can take away some of the stuff we're doing. There was the great line earlier about start small and build up. This is all about starting small. This is how you kind of get your foot in the door and get going with some of this stuff, which can then build up into wider data science working. I'm going to be very quick with this bit to try and kind of keep to time on it. Basically, what I just want to do is kind of unpick very quickly the difference between these three terms, which are often used pretty much interchangeably by people who don't actually understand what they mean. So analytics is all about taking data, usually kind of visualizing it, dashboards, charts, interactive databases and things like that, and using that to communicate insight and understanding beneath that. So it's about kind of, for example, with the presentations we saw this morning about the charts, about who was seeing the main stage at the festival, when the bar was getting busy and things like that. That's analytics. It's about understanding where those peaks and troughs and that interest is. It's not really the focus of my presentation today. Next thing is big data. Big data does not mean a database, set of data that is too big for you to fit in an Excel spreadsheet. It may be large, but there's more to it than that. It's also about data that updates very quickly. So having a data collection that you run once a year isn't really in the spirit of big data. This is about stuff that's updating continually, whether it's supermarkets judging what's happening on their shelves, whether it's power companies monitoring demands. It's also stuff you make decisions on quickly. If you're the national grid, you don't want to do something where you analyse what's happening with everyone putting their kettle on at the end of the England game. It goes to a meeting in 3 weeks' time, and then you make a decision that you needed more power on the network at the end of the England game. No, you needed to make that decision at that point. So that's why velocity is important when you're dealing with big data. Big data also touches on the idea of variety of information. So not having everything in neatly defined and specified collections that comes in with a nice unique identifier and a nice description on each column. It's often picking up messy, sometimes incomplete bits of information and moving those together. And it's the combination of those three things that is what big data is about. Big data isn't really what my presentation's about, but I think it's important to unpick that. This is what I'm more talking about, which is data science. There was a good bit in the presentation earlier about a lot of the different skills that make up a data scientist, and that often it is difficult to find someone who does all of those things. But the key thing behind this is the idea that it's not just about being a specialist in a single area. You can be the greatest coder there is. That is not necessarily going to help solve the business problems because you don't understand what the problem is you need to be solving. You could be a great expert of what's going on, but if you don't know what's possible in terms of building tools, it doesn't get you to where you need. And again, the example this morning, the Trussell Trust one, I thought was great. If you're looking at issues to do with food banks and usage of those, the initial conceptual leap isn't, we need to do mapping, we need to be looking at distance travelled around that, we need to be looking at kind of splitting that by usage. That's a piece of lateral thinking that takes you to where you need to be, that comes out of understanding the problems, that comes out of understanding what's possible to build, and that comes out of being able to understand how you can analyse data and pulling those three things together. And that, I think, is the fundamental thing about data science, is it's about combining all of those things. It doesn't mean you need to be the greatest programmer out there. It doesn't need to mean that you need to be the greatest statistician out there, but you need an understanding of all of these different areas to pull it together and come up with business solutions. A couple of quick anecdotes I'm going to do before I get into the main part of the presentation. Target are an American supermarket. They realised a very good way to boost their profits was to target people who are becoming parents. I've recently become a parent. I understand that you then go and throw pretty much your entire life savings at this tiny little bundle of joy, whether it's clothes that they grow out of in the time it takes you to blink your eye 3 times, whether it's nappies, whether it's toys that they then show absolutely no interest in whatsoever and you throw out. So they did a lot of work analysing behaviour of what people started buying when they became pregnant so they could then target them with mailings that mean that you would come there to buy all this stuff and increase their profits. They got very good at it. At one point they sent a lot of mailing out to an 18-year-old woman who was still living at home with her parents. Next day, very angry father storms in, store manager up against the wall. How dare you? This is an insult to me, my daughter, my family, etc., etc. Profuse apologies. Sorry, here's a lot of extra vouchers. Please go away. Please don't kill me. About a week and a half later, same father came back to the store, rather ashen-faced. His 18-year-old daughter was pregnant. They knew, he didn't. But again, it just showed, part of the reason I bring that example up, which I think is interesting, is that the data they are picking this up from, people going out and buying stuff in store, that information isn't designed for you to build a predictive model about pregnancy. But actually, if you look through that information, you can do it through there. The information is there for you to pick up and use to do that. If you know the right techniques, if you know how to do it, if you make that lateral thinking jump and know this is the business benefit out of doing that. Similar one with a little moral. Flu epidemic, I forget exactly when it was, I think it was 2010 in America. Google found they could track the spread of it about 2 to 3 months faster than the government could. US government would get GPs to send stuff into their analysts who would then conflate it and build stuff on that would track where it was going, which required people to get ill, be ill for long enough that they wanted to go to the GP to fill the forms in, that to go in, very long lead time. Google realised that when people get ill, they search on the internet for flu symptoms and for ways to cure that. They had a real-time way of monitoring that, and they knew people's locations as well. So they were able to do a much better job of tracking it than the US government could, which was really impressive, and they made a lot of headlines out of doing this. There was then another flu epidemic about 3 years later, and the model fell apart on them. Since then, they've rebuilt the model and it works again. But again, there's two things out of this. Firstly, it's about thinking where you can get the information you need to be doing this stuff. Not thinking, I need this information, we therefore need to set up a way of collating it all in a go out and ask people. And secondly, when you come up with your brilliant model, don't become so cocky that if you find in 2 years when it starts falling apart, you look like a charlatan. Because it even happens to the best of them. This presentation has 4 main chunks to it. What I'm going to do is at the end of these chunks, kind of leave a little breathing space there so we can kind of take some questions around those rather than having all the questions at the end. First bit, machine learning. How do you transition from tried and trusted analysis techniques to computer-driven techniques that may be viewed as a black box? So this is very much the whole kind of, okay, we've got regular analysis we do here. We want to be doing data science because I want to be the sexy profession of the 21st century. But actually what you can end up is something where you go back to the business and say, yeah, the computer kind of says this is why we should be doing this. I don't quite know why. So this is about how we get there and why we go there. So firstly, why not use a regression model? It's worked well for hundreds and hundreds of years. You put your spots on the graph, you draw a line through it, we can see whether variables are statistically significant, we can do analysis of variance, we understand how this works. What's wrong with all of that? In terms of the work I do, 2 key things. Firstly, combinations of events, which regression approaches can struggle with. So for example, school appoints a new finance director. That's all well and good and great, brilliant, that's going to happen a lot of the time, doesn't necessarily mean there's a problem there. They may then submit their financial statements late. It could be the computers just crashed or something else came up that was a problem with that, so maybe not an issue. Their spending forecast might be a bit out. Well, maybe their central heating system broke down and had to spend a load of money doing that. Maybe they had a capital project on this year. Each of those individual things in and of themselves could have a relatively low risk weighting. Those 3 things together may well suggest that that new finance director really isn't in control of what's going on. So I'm interested in knowing when these 3 things happen together, more so than when they happen in isolation. Now, if I'm feeding these as individual variables into a regression model, then actually it doesn't necessarily know that we want to look for this combination of events. So it won't pick up that these 3 things together could be really important to us. Secondly, linearity. A lot of linear regression stuff works in a linear way, clues in the title. So within schools, a lot of the funding they get is related to the amount of pupils they have. Therefore, if you have a big reduction in the number of pupils, I am very worried. Trying to run a school when you've only got 10 kids per pupil, that is going to be difficult to do. You are going to struggle financially and you are going to run into problems around that. If you've got a small number, a small reduction in pupil numbers, I might be a bit concerned about that, but you may well kind of get variations between years. If your pupil numbers are going up, well, that's pretty comfortable. But then, since we're working in a linear way, if I'm very worried about a big reduction in pupils, I'm really, really happy if your pupil numbers are going up and up and up. Actually, I'm not. The effects of a school, if you were kind of increasing your pupil numbers 50% year on year, there's a lot of challenges you've got to be able to manage that. So this is not where I want to end up. But a linear approach says if I'm unhappy there, I have to be happy here. Now, okay, I can go in, I can create a customer function that works in the way I want to do around this, that kind of tells me that actually as we go along, that I'm very worried down there, I'm happiest with a small increase or stability, and then I'm a bit concerned if we're growing too quickly around that. But in the morning session, I talked about all the different bits of data we've got out there. Do I have the time to be sitting down for each individual variable and trying to custom fit a function to it to feed into a linear regression model? Actually, I probably don't necessarily have that time, and certainly if there's a way that can save me time doing that, I'm all ears. So this is where we move into something known as decision tree learning, which is a quite powerful type of machine learning. And I'm going to give you a quick example based on Titanic. Anyone here seen the film Titanic? Anyone here like the film Titanic? Okay, prejudicial question. I don't, but hey, I won't blame people who do. If you like Titanic and the Celine Dion song, then I might actually get a bit more opportunity. Anyway, 38% of people on the Titanic survived. How do we come up with a model that actually tells us who's going to be a Kate Winslet and survive, and who's going to be Leonardo DiCaprio and fall into the sea, even though there was enough space on that bit of wood for both of them? So basically, how do we take all the information we've got, and you can throw everything in this, you can throw in name, you can throw in where they got on board the ship, you could potentially even throw in height, you could throw in what class they were in, you could throw in what ethnicity they're in, throw it all into the model, and what decision tree learning does is look across all of these and try and find a way of splitting this into two groups where you've got the biggest difference between, in this case, survival rate. So group one are the people who are most likely to survive, group two are the people who are least likely to survive, based on splitting on one individual variable, and then within that you split it down more and more. So unsurprisingly, actually gender is a really big thing here. So females, 74% of females survived as compared to 38% on average. What you can then also see is actually males aged under 7, 67% chance of survival. You then look at basically adult males, which in this case is anyone 7 or up, so tough if you're a young teenager, 17% chance of survival. So this is working in actually kind of a relatively kind of basic way that's easy to understand. We're just taking our data set and looking across everything that was in there and saying gender is an important factor, and if we split out men and women, we get something really important and really informative out of that. Here, this is doing combinations of factors. I didn't tell it to define children as being 7 or under. It looked across all the different ages it could have split. Could I split it 4, 5, 6, 7, 8, 9, 10? And it looked across all of those and combined it with gender to say males aged under 7 is what we're interested in. We're less interested in females under age 7 because most females survive anyway. Age is a less important factor as a combination if you're female. But if you're male, that's a really big difference. A 17% chance of survival compared with 67%, that's massive. And this here is just a visualization of what we've done. So we start off with our main data set, and these are our females that have a 74% chance of survival and make up 35% of our data set. These are our males. We subdivide these by adult males, and then these are our under 6-year-olds, and then this is then splitting it further between whether they had a sibling or not.
Could we have measured the anti-fouling on the bottom of the Titanic? Because the anti-fouling on the bottom of the Titanic meant you could go faster, so therefore it was going for the blue ribbon. If you want to go for the blue ribbon, you've got to sail the Great Circle route, therefore you've got to go up into the ice zone to get the blue ribbon, which was prestigious because it meant more passengers would use your boat. And that's the reason why the Titanic backed an iceberg.
Yep. But what I would say there, actually, good bit of trivia and not something I knew, so kudos to you for that. But also, I'm going to take something out of that, and please don't take this as a dig to you at all. At the start of this, I said I was building a model that was predicting the passengers who saved it, who survived. Now, actually, the chance of the Titanic sinking or not is not what's of interest to my model. And there's a key bit there that, yes, I can do that bit of analysis, potentially, and it could be very interesting. But it's not what's of benefit to the business. And that's one of the things that's often key about the data science stuff, is am I doing it because it's a really interesting bit of analysis that I want to do and it's cute and it's an area I want to learn in, or is it something that's actually going to be transformative when I speak to the person at the end? Sorry, I know I'm kind of extrapolating quite a bit there. So final bit on this, we could then subdivide this further by how much the ticket costs, whether in the family group, whether they're on high deck, whether they're a low deck. But the key thing about all of this is I've used something which is, with the algorithms behind this, actually really quite powerful and cutting edge machine learning approach. And the stuff coming out of this, you can explain very simply and very clearly to people. And it's picking up on a lot of the things that are a problem with traditional approaches. So I think that's really powerful as a way of getting into this stuff. You can then build further up. So one of the problems with this can be that it overfits models, that it looks very specifically at the information it's got and say, in this case, it predicts things wonderfully for the Titanic, but if you then had, what was the sister ship for the Titanic called? I forgot. Olympia. Let's call it Olympia for the sake of things then. You may well find if the Olympia sailed, something would be entirely different on that because this went through, and if we overtrained this, it would say people named Mr. Smith had a lower chance of survival, or people with blue eye colour did, or something like that. So you then can start building up from this into something known as random forest. And this, instead of just having a single decision tree, has a lot of them. It can have tens, hundreds of different decision trees. And with each of these, it takes a subset of the data, and it takes a subset of the variables. So it only looks, in the Titanic example, say 2/3 of the passenger list, only looks at 2/3 of the information we've got, so it may not look at gender for this one up here, and goes and fits a model based on that. Then goes back, takes a different 2/3 of the passenger list, a different 2/3 of the variables, fits another one, and then works its way all across those. And by doing that, it stops it being overly precise on things because it's testing your data set multiple times. It's as if you've got more data than you actually have to test on, which is really powerful, but it becomes a lot harder to explain exactly what's happening without this because we no longer have one cute thing that's just kind of saying, you know, women here, boys here, adult males there. We've got a combination of a lot of different things. So it's useful to go in through an initial decision tree and then see if this tells you anything different by building up to that, which is the fundamental bit on the next slide, which is about saying, I can do all my fancy data science decision tree learning here, but I can also go back and just compare how that stacks up against logistic regression. And this is actually a kind of a halfway House-Lasso regression. It's a slightly machine learning kind of approach around logistic regression. And in this case, basically the red variables are the ones that we're most concerned about, and the green variables are the ones we're least concerned about, with yellow being in the middle. But what we may find is our machine learning stuff flags up stuff that we don't see on our other models, or potentially in some cases says, well, okay, we're really concerned about this on logistic regression, but here we're not so worried. And even if what you do with using these techniques is just use that to say, we need to think about that a bit more, and we need to think about this a bit more. Speak to some subject experts, understand why this might be the case. Have we got caught up with some cross-correlated variables or something like that? Even if you just use it at that level, and then go back to fitting something on a logistic regression approach, you've added value through doing that. And you're starting to dip your toe into what's happening with this data science work. And then steadily you can build up to the point where actually this is the primary way you're doing stuff, if it adds value to where you are. But it doesn't just need to be I'm either doing regression or I'm doing machine learning. Any quick questions on machine learning stuff? Yes, sir.
Not on machine learning, but one of the questions is how do we pick the variables to block on?
Okay, so in terms of this, one of the advantages of the machine learning approaches, and particularly something like decision tree learning, is it is really a case of feel free to throw as much stuff into this as you want. And one of the things that can really help about that is the way it often deals with cross-correlated variables is quite neat. So for example, I've mentioned this to someone else earlier, the fact that if you want to know a good potential predictor for the quality of schools, look at height above sea level. Works surprisingly well. Reason is, coastal towns have higher levels of deprivation than inner cities, than larger urban areas. Therefore, actually, you're finding a correlation around deprivation that's just manifesting itself in a geographical way. Now, if you fed something that had both geography and deprivation into a decision tree model, what you'd find within that is it would be finding actually the more powerful split is around that deprivation indicator. So I split based on that. At that point, if I then look at geography, it's not telling me much more than the deprivation thing did. So it gets junked and put right to the back of the queue. So at that point, actually you can use this as a way of saying, actually I've got 100, 500 different variables. Let's throw them all into this and see what it tells me coming back from there. I would say do keep going back to looking at professional judgment though, and people who understand what's going on around it, otherwise you will get caught out.
Does the data set have to be kind of highly structured? Does it work with relatively unstructured data?
It works pretty well with a range of different data. In fact, one of the things that it is very good at is dealing with categorical data. So, for example, a regression model, if you've got anything that's kind of, A, B, C, D, something like that, you need to code it into some kind of dummy variable, 1, 0 or something like that. Since this is just splitting stuff up into groups, it's not so worried about things like that because it's just saying you're here or you're here. It doesn't have to say group 2 has twice the value that group 1 has. So if it's kind of looking at first, second or third class, it doesn't need to be plotting that in a linear way. It just kind of says first class was much more likely to survive, third class was less likely to survive. We'll just split it up like that and let the data tell us. You do need to kind of make sure all the data is linked together so it can do it, but it'll handle missing data relatively well as well, because it'll look into that and just kind of go, male, female, unknown. Well, okay, is unknown something that if I split that out from males tells me a lot more? If it is, I'll split it out. If not, I'll just ignore it and group those two together and just say female or not is the key question here.
Do you have any examples which are sort of not one row per outcome? So, for example, say one but like height of students. So there you'd have to aggregate in some way.
No, well, actually, with the way the decision, it can split multiple times on the same variable. So with age on this, it was kind of splitting, say, under 6. If what you found was actually people were being very generous towards the elderly on the Titanic, then it could split under 6 and over 60 as well.
Sorry, sure. And then multiple rows per outcome. So say you were looking at the outcome of a school level, but you've got height of pupils. So you've got multiple heights of pupils, but they all have the same outcome.
Okay, good question, and one off the top of my head I don't know the answer to. Pick it up.
You could take something like average student height, or extreme 95th percentile, or whatever. You can generate as many variables as you want off that. But I was just wondering if you had an example of that kind of
not specifically off the top of my head. I'll see if one pops into my head before the end of the presentation, but unfortunately not.
You're using this table and all the machine learning to indicators of what is causing an issue. Have you ever come across an instance where something's flagged and you don't know why? And so what do you do about that?
Well, actually, that's where it kind of gets interesting with stuff around that. And actually, so it does happen. And I'll take it back to some of the Trussell Trust example this morning, which is the whole thing about payday loans that they hadn't spotted. The key thing about that is what you'll often find is it's something you didn't pick up and record in the data in a precise enough way for you to really understand what was going on. So say, for example, on the schools one, if I'd had something around schools and I hadn't put deprivation in there, but for some reason I had put height above sea level in there, I'd be getting that and kind of go, that makes no sense whatsoever. And what that tells me is there's probably something else going on in there that I'm not measuring yet. And that's when you need to start digging down. And what you would often do with that is look at the specific cases it's highlighting, do case studies of those, and then understand what's going on. So in the Trussell Trust example, if they were looking at the people who were having all these debt problems and actually went out and started saying, there seems to be a lot of debt problems at the moment, someone would say payday loan pretty quickly. Then you start differentiating that and bringing you back in the game. At this point, I am just going to jog on because unfortunately we are going to run out of time somewhat, and there's a few other things I want to pick up, or quite a few other things I want to go through. Some of you may have seen this before. Can anyone tell me what the bottom half of that sign says?
I'm out of office, please email this other person or something like that.
Yeah, so basically this was a council worker somewhere in Wales who wanted a Welsh translation for what was on the top of that sign. They emailed the translator was out of office, they're out of office, the system message was in Welsh. That's what got printed on the sign. I love that. I really hope the person who did the sign could speak Welsh and knew exactly what they were doing when they were actually printing the sign up. The reason I put that there is because it's a cheap laugh, but also because it also represents the way in which a lot of analytical software and analysts interact with words. We like numbers because they're nice and qualitative, and we can really kind of draw patterns out of it. This we can kind of say how many letters are in each of these, because I don't speak Welsh at all. And I understand what the individual letters mean, but I can't actually get any sense out of that. I'm going to run through a few slides quite quickly here, and again, the point about these is making the leap into data science, getting started with stuff. So in terms of text, we can do basic stuff. I'm sure most of you will have done something similar to this at some point, just counting the number of words that come up within a particular document. And you can do stuff with grouping different types of words together, so academy, academies, academisation. You can say they all have the same root. So there's stuff you can do around there, and you can refine it quite nicely. That's fine. It's not particularly sexy. It's not particularly data science, but it's a first step. Second thing, which I think is more interesting, is doing stuff around actually categorising information. I'll come to this example itself in a second. But to give an example of one of the things we did within the Department for Education, we did something which was basically going out and asking teachers about what were drains on their workload, wanted to know what they thought tied up time, and wanted to understand more about that. Got tens of thousands of responses. So deadline closes, we've got 50, 100,000 responses on that. A lot of interest in that. And of course people want to know what it's telling them as quickly as possible. And it's going to take quite a long time for people to read through all those responses. We need to do that to get the full level of quantitative information. But it'd be great if there was a quick way we could get through this and say, well, actually, these many are saying something about Ofsted. These many are saying something about kind of paperwork to do with marking stuff. These people are saying stuff about health and safety. And this is where this categorisation approach kind of comes in. This is something known as a bank of words approach, which is based on something known as naive Bayes. These are all US Congress bills. So we've got a name of it here, and within this example, it's just setting it up to say, based on the name, can we work out what type of bill this is? Is this a health bill? Is this a defence bill? Is this a foreign trade bill? And actually what it does is it looks through each individual word, or depending on how you set it up, combinations of words. It says, what are the chances of this word turning up in a health bill as opposed to a defence or a foreign trade bill? And in some ways it actually kind of builds it up further. So it can actually say something like this is definitely not going to be a health bill. This word never turns up in there. So in this, I've kind of flagged up some obvious bits. So health, it's talking about patients, hospitals, vaccines, medicines. Those are words that come up frequently. If I'm seeing those kind of words, it's much more likely to be a health one. If I'm looking at defence, military, army, defence, security. If I'm looking at foreign trade, it's probably suspending a temporary trade duty. No idea why that's so popular in American politics, but apparently it is, according to this data set. Now, the idea behind this is you have to train a bit of this data up first, so feed something of it in to say these ones were foreign trade bills, these ones were defence bills, and then let it running on the rest of the data set. But the key thing around this is it doesn't know what defence is. It doesn't know that defence is to do with the army. It's just trawled through that data and made that connection within there. And that's what a lot of this machine learning stuff is doing, is it's going through a level of information by the amount of data it can churn through that you won't be able to do as a person. A couple of things I like about this. One is that you can pull stuff out so you can actually see reasonable things. These words all make sense in terms of this. If it was coming up with ice cream as something that typically comes up with a defence bill, you'd worry somewhat, but you can be checking those things in the diagnostics. This package, R Text Tools, which is one of the packages you can get with R, is great for doing this. It's got great documentation online. It's set up so that this is what it does, this categorization stuff, and just that. It's got about 7 different models in it. So one, two, 3 of those models might crap out entirely with the data set you've got, but the other 4 may well work. And you can compare the results across the different models to be seeing, in this case, Model 1 and Model 2 accurately predicted that the name should be mapped across the category 21. Model 3, got it wrong, thought it was category 10. So again with this we can set something up where if you're in a situation where you want to be concerned about saying I don't want my model to be coming out and say categorising stuff and getting it wrong, you can say I only want to categorise stuff when all 3 models are in agreement on this. If I've got ones where they're disagreeing, I'll say actually I don't want to go near it and categorise it. So again, in terms of getting going with this stuff, you're not immediately diving into a model where you're claiming it knows everything. You've got something where you can be setting thresholds around this and walking in quite steadily with that. So this, I think, is a neat way into doing stuff around text analysis. The R Text Tools package is very good to kind of get off the shelf and start working with, as I say, good documentation around that. A less safe space is sentiment analysis. Basically because sarcasm, irony and things like that destroy it completely. In fact, this graphic here is taken from a site called crowdflower.com, which specialise in dealing with sarcasm and irony in text analysis by the highly scientific method of having a group of people who read through it by hand and categorise it for you. It's a problem that even the best things still struggle with. There are ways that you can do it. There's a package in the again in R called QDAP that will do you lots of very neat visualizations that will look at positive and negative words and things around that. But you're starting to move into more experimental areas there. And this is why I'm saying this isn't something you go directly to, you'd build up through other things. If you really want to go for broke, you get into natural language processing. We can identify names, locations, dates, times and things like that. You're getting into quite complex areas here. This is the kind of stuff you're not going to be able to kind of knock up in 1 week as a proof of concept. This is a long, sustained project you're getting into. And I think one of the big things about transitioning is the categorization stuff you can go and start doing very quickly. If you then start getting some buy-in with that, you can then start building up into these areas rather than trying to get 6 months signed off to go and do some really advanced stuff on that. I'm not going to dwell for questions on the text analysis stuff just because I do want to focus on a couple of other stuff, but feel free to pick that up at the end if you've got questions on that. So I've mentioned the R software package a couple of times. I think it's absolutely great. It's an open source package. It's developed by a community of people, and it's the kind of thing which a number of IT groups will basically have kittens about because there's not a service level agreement for it. It's not off the shelf. We're not buying a Microsoft product. Why can't we just have a Microsoft product instead? So I just want to kind of run through a few key things when you're starting to get into this open source environment, which I think is critical to getting the most out of data science. Firstly is training. If you want to find PowerPoint training or Excel training, take your pick. There are hundreds of people across the country that will do that for you, nay thousands. If you've picked up a nice JavaScript package that someone in Silicon Valley's just dreamed up, yeah, good luck finding someone to actually sit you down and take 30 people from your workplace through that. Things you can do to help with this. Firstly, actually try and identify the skills you've got within the organisation. A lot of times you may well find that you've got a group of graduates who actually did a load of this stuff at university, but they're working on something entirely different and would like to be playing around with this stuff, whereas you're sitting here going, I'd love to do this stuff, but I've got no background in it. So see if there's a way where you're doing this stuff about just making it visible enough that people who have worked on it before have a way of feeding that knowledge in. Don't work in silos, work collaboratively, and basically don't have one person over here who's trying to solve that problem, another person over there that's trying to solve that problem, and you're both battling with different problems. Come together, share your knowledge on that and work through it. There's a lot of good stuff online to support these packages. There's also a lot of rubbish. There's also the problem with a lot of the stuff is you get a couple of really small tutorials And then after that, you have to search through kind of forums on websites and things like Stack Overflow and things like that, which are all about this specific line of code in mine doesn't work, and oh, you missed a comma off there and things like that. And there's often a gap in the middle about having a more structured way through it. There is a lot more being developed in that space. There's a lot now with massive open online courses that are plugging that gap. You do need to search around a little bit for it, but if you do search, you will usually find stuff. Good knowledge management. The job is not done when you've delivered the product. The job is done when you've delivered the product and written up how you've done it. Organisationally, that's very difficult, because when you've delivered the product, there's the next priority, go and start doing that. And you end up with a number of things where you don't have enough understanding across the organisation about how this stuff was done, which leads you to only one person knowing how this works. So you do need to fight to make time to make sure these things are written up. And if you've got knowledge management, you find that good coding knowledge goes a long way. Someone who can code in SPSS or SQL or HTML or something like that, they know how to code, they can probably jump between those different packages relatively easily if you've got some good knowledge management there, because it's all the same basic concepts. Security implications. This is, again, to a certain extent, another start small and build up kind of thing. One of the key things I would say around this is there's a lot of places where you won't get past step one with this stuff. How can we trust it? Wasn't it just made by a 14-year-old in their bedroom who was probably trying to hack the Pentagon at the same time? A lot of times with these things, we're talking about packages that are being very widely used. R is the kind of thing that is used to underpin drug trials in America. So basically, you can get drugs signed off to be used on the American market where all your analysis about efficacy has been done on R. Now, that's a life or death decision that the FDA are making to say we trust that. That's a good thing to be putting back and saying, that kind of shows this stuff probably is reliable and probably is secure, because we're talking about patient records in this stuff as well. So go out and just start the argument by saying these things are generally being very widely used. Yes, you do need to be careful where some of these things are picking up user-defined packages. So pick things, start off by picking areas that are in wide usage, that do have a lot of proof of concepts out there. If you want, start off by putting things on sandbox machines. Have a machine that's off the network that you start playing around with it there and check that it seems to be working safely. Use anonymised data, or even better, use synthetic data, which is something where you take the data and instead of just stripping the names off, it goes and generates something which has the same characteristics, but is entirely fictitious. The reason that says synthpop is not because I like the Eurythmics, it's because that's a package in R that creates synthetic data and does it relatively easily. Finally, stability. Basically, if we don't have an SLA, then we can't trust it and it will fall apart. There's a couple of things around this. If you really want the safety blanket of an SLA, there are companies you can pay to do that. Revolution Analytics, which has now been bought by Microsoft, specifically was in business to take R, which was a free program, and say, we will sell R to you. We will give you a free package if you give us money. In exchange for that, we will provide you with a service level agreement. If it stops working on your machines, we'll come in and we'll get it up and running for you. If you run into other installation problems, we'll come in and we'll help you do it. Basically, they got around that first thing by saying there was a market there for people who wanted to pay for free software. And they did it successfully enough that Microsoft said, we're having a bit of that, thank you very much. That's a cash cow right there. And actually, again, so there's another thing about, come back to the R package, there's other things, Python and things like that, but I use R a lot. In terms of people saying, we wouldn't want this on our systems. Would you be okay with SQL Server on our systems? Well, yes, that's a reliable package. SQL Server 2016 comes with R pre-installed. Work that one out, IT people. You can't have one but not the other now. So actually going forward, this stuff is being ingrained into the packages we've got because it's so fundamental to the way people are going to be working. Other things we can just say around this, in terms of if we're going for wider stuff, look for a large user base on packages. If there is a large user base, then it's the kind of thing that will sustain, that will be stable, because otherwise it wouldn't have built up that user base. Make sure you've got an idea of fallback options. If it does suddenly stop working, what are you going to use instead? Use small pilots and build from there. Don't convince everyone that Hadoop is the future and you're transitioning to everything in 3 months' time to Hadoop. Start off with something small, make sure it works, build up from there. there's another bit of this about saying, one of the concerns is saying, well actually, okay, this is being developed by this group of people at the moment. What if they stop developing it? Well, if it does what you need it to do, who cares? It will still do what you need it to do because you already have the package. With a lot of this open source stuff that's out there, the code's out there. You know, it's not that they're going to withdraw it and stop it working. Anything that is potentially server-based, you might have more of a concern about. But most of these packages, they're pre-compiled code that you're running in your area. So it doesn't matter if it stops developing. It's not like you're going to be going around with an iPhone 5 when everyone's got an iPhone 6 and no one's going to talk to you anymore. If it does the job, it will still do the job.
Sorry, on the upgrading point, I think a concern we have quite a lot is when packages are upgraded, code you've written under previous packages no longer works or doesn't work in the same way.
Which is actually a part of the reason why sometimes you actively don't want to upgrade. What's interesting is that there's a view that kind of says actually supplier-based packages are less prone to that. Actually, the new Microsoft online reporting package, Power BI, that is something where we've had some reports we've built on that kind of break 2 or 3 times because they're moving over to a more open source development environment. So it's going to be the kind of thing that I think will become a greyer and greyer area. But certainly, yeah, if you have got something where, like Firefox updates itself like 4 times a day or something like that, if you've got something like that, be thinking, okay, if it is an upgrade, we need to test the upgrade before we put it in place. Now that said, in terms of not necessarily upgrading, don't go that far. That's scary, that. American nuclear missile system being controlled on 1970s computers that they can't find replacement parts for anymore. Apparently it's going to be sorted by the end of the year. So, open source software. Any other questions on open source software?
I think the point version control is...
Yeah.
So, I mean, I use Ruby and RSpec and all that kind of stuff, and they change it all the time. And you basically, you have half a day working on it. I think that's one of the main concerns. Presumably, was it Resolution Analytics controlled that for you?
Yeah, so that again probably would have been something that's part of the SLA. They would have said, okay, you've got these various bits of code. When this upgrade is coming up, we'll go in and test whether the code is going to break, whether you do this, and if it does, we'll track down where it would break for you.
So there's also RStudio Pro, which has an option of saving your R and then all your packages as well at the current version level, and attaching it to a script to be like, I ran it under this entire compilation, because you can be talking about 100 packages, with their dependencies.
Yeah.
But yeah, check out RStudio Pro. We find that.
You can get these problems with JavaScript.
Yeah.
This is not an R problem.
Well, no,
It's
it's open source problem. Yes.
No, JavaScript's isn't an open source as such.
I'll move us on there before we kind of go down the rabbit hole. Okay, data visualization, geospatial analysis. So the idea behind this bit of the talk is kind of saying that actually, again, you come to conferences like this, you see big whizzy stuff on screen and you think that's great, and then you go back and spend the next 8 months arguing to get some budget to go and get 5 Spotfire licenses or Power BI licenses or something like this. Or you want to put stuff on Tableau that's kind of got a free trial you can do, but say actually we're worried about putting the stuff up there because, is it going to be secure with the information we've got and things around that. And you just don't make any progress because you're having long conversations around that which really aren't getting you anywhere. Now again with this, what I'm talking about here in terms of this presentation is getting you going. The first step and a little bit of momentum behind that. And the first step around a lot of this stuff is actually getting people to want to move on to those kind of packages and those kind of areas and understanding why an interactive dashboard or something like that would actually help them. So I'm going to give a very basic example here, but it's just an idea to show what can be possible as a start approach. So I was talking about some of the kind of risk analysis stuff we were doing. The initial stuff that we built as proof of concepts, we built basically in Excel using a combination of Visual Basic and a certain degree of ingenuity. And so I just wanted to give an example of some of the stuff around this. So basically this is our default position, nothing's different here. I can go and ping open a nice little control panel here. This control panel persists, however many different tabs I move around, it floats on the top nicely. I've got different combinations within here. And the idea of this is basically allowing people to play around with different policy options. So part of the idea behind this is sometimes what you struggle with analysis-wise is you go and do lots and lots of analysis and you go to people and you say, this is the solution. And they kind of go, really? I'm not quite sure I believe that. And you spend a lot of time haggling with that because they haven't gone through the process you have of understanding all the other different options are out there. And they need to have a certain degree of actually being able to play around with the underpinning data to really get the understanding of why this is the solution you've come to and why there isn't necessarily a magic bullet there. So the idea behind this approach was saying, okay, this allows you to play around with some different approaches. So within this, I can take a scenario that says, in terms of all of these policy impacts being yes, they can be no, and my chart's updated behind that, or I can make policy impacts 2, yes rather than a no, similarly with policy impact 3, and I've got stuff going on. In this case, it's just a chart. I could have put anything I want within Excel within that. And I've got this kind of relatively neat box here, which is telling me whether I've come up with something which is a scenario that we've looked at before or a weird combination of events that we haven't. And go around and play with it, play around with another one here. And it's giving someone the feeling of being in control and working with stuff and working dynamically, which can be that first step to when they then start to say, oh, but it would be great also to be able to X, Y, and Z. Can I have the money for that license for the BI package now? Okay, yeah, now I see where we're going with that. Now I see why we need this. In terms of this working, this menu bar here is just a Visual Basic form. So if you do an internet search for Visual Basic Forms, it tells you how to put something like that together. And all it's doing, so for example, with this, if we look at this cell here that's currently a 2, I'm now going to change it to a 1. And then I've just got formulas linked through to that 1 there, and that's what updates the chart and other things within there. So there's nothing particularly complicated going on within this. I've just created the impression of it being a bit more complicated than it is by using that Visual Basic form over the top of it. Which again, as I say, is a way of being able to kind of quickly develop some proof of concepts. You'll probably find within most organisations you've got people who are very familiar with Excel and Visual Basic, and that gives you a way to start building up where you want to be going with this stuff. And then you try and make the transition through to, we want to move to this new flashy BI package that does all of this stuff, once you've shown the business need for it, as opposed to having the argument on the basis, well, we probably could do this, and it looked good at the presentation I saw. Geospatial analysis, so this is some mapping stuff. Colours don't come out particularly brilliantly on here. But on the left-hand side, we've got a school. There's red areas where the majority of their pupils come from. Yellow areas slightly less, green areas a little less than that. Here's the school to the south of it. We can see here there's a very defined boundary at this point. If you're here, you go up there. If you're just below that boundary, you'll go to this school here. In the context of what we're doing, this is kind of quite important for understanding areas served by schools. It's also quite important to know that if there's a big new housing estate that's coming here, those people are almost certainly going to be going to that school here, not this school here. If we're having conversations with schools about where we think growth in pupil numbers is going to be, that's a very useful bit of information. If that new housing estate is going in this bit here, it's going to be split across the two schools. That's something that actually looking at it as something that's mapped is very powerful. Here I'm just comparing that same school with one over in the east. In fact, slightly odd, I've gone to one slightly further away. This one's closer. You'd think that one will be much more in competition with the school there. Actually, it's not. You have to zoom this far out to actually see the catchment area for it. It's an ex-grammar school. It attracts people from far away. There was some stuff we saw this morning in terms of the mapping stuff that the Turrell Trust were doing. Looked absolutely great. One of the problems with a lot of this stuff is you look at it and go, yeah, I have no idea how they've done it. I have no idea how we would do that in the environment we have. I don't see how to get from where I am to where they are. So here's a very quick kind of jog through how you can get to that point. Google Maps. Everyone knows Google Maps. That's fine. People will kind of trust that. You can start embedding Google Maps into spreadsheets. There's a website here, which I'm going to direct you to because I don't have enough time in the session to go through the detail, but ococarbon.com has a set of stuff which allows you to put basically queries of the Google servers directly into spreadsheets. So if you want to know the distance between 2 points, and you can enter them as postcodes, place names, whatever the hell you want, in exactly the same way you would on Google, it will return that result directly into the spreadsheet, either as a distance or a travel time. You can also embed Google Maps directly into spreadsheets. So the way this quick one works is you write whatever place names you want in there, cities, postcodes, landmarks, anything you want like that. That will dynamically update within the spreadsheet you've got. Again, the ococarbon.com website shows you how to do it. I haven't got enough time in this presentation to go through the interim steps. But it's a transformational thing. Suddenly you are doing some geospatial analysis and you've got stuff like that going on. And what you probably find with that is people start asking you to do more of those things. At which point, sorry, jogging through those because I had more content just in case I had more time. I had the feeling I was always slip through this. There is a slight issue with Google, which involves sending your data to Google's server, which you may not be happy with. There are also some issues in terms of usage restrictions on it, which is where something called Leaflet comes in, which is a JavaScript package. JavaScript itself, not open source, but Leaflet is an open source package built on JavaScript. So just to kind of get myself in the right place around this after you kind of threw that aside and from left field there. No, that's fine. The advantage of this is all the calculations it does are done on the local processors, so this is secure stuff. Actually, there aren't any usage limits on this because, again, it's burning your own processor power, but it is a bit more complicated. And the idea behind this is often, well, we need to have a proper environment where we've got all this infrastructure around that allows us to do this. Cobblers, you can do it with Microsoft Office and Notepad, and we did because when we started off, that's what we had. The idea we did behind this is basically drafted some stuff up in terms of Notepad, in terms of looking at this Leaflet package, which has some very good tutorials online with it, getting some fixed web pages out of that, and then actually using Excel to make those dynamic. So a couple of things to step through this. Doing HTML code within Notepad is a pain in the backside, because if it fails, it's not going to tell you what's wrong. It's JavaScript, there's a website called js.do. Throw your code in there, it bug fixes it for you. It tells you where your mistakes are. If it's HTML code, put it in validator.w3.org. It tells you where your mistakes are. These are kind of things in a nice environment. You'll have something like Sublime Text that does all this for you in one place. If you don't, this is your workaround. Similarly, I'd love to have a web server I can play around with to go and do all this stuff. But particularly when we started, we didn't. So this is why we used Excel. Maybe we had a lot of our data on SQL Server. We pointed a pivot table at it. Nothing rocket science in that. What we then did was use Excel to pull the data together we wanted and fed that into our HTML. And what I mean by that is we started off with basically a flat bit of HTML that we wrote in Notepad using those packages, following the tutorials on the Leaflet website. And then there are certain bits, so if I want points to appear on that map, I have to tell it the latitude and longitude of those points. So I've just got my HTML code through there, and at a certain point it says latitude equals cell C6. Longitude equals cell C7. I've now got a dynamic bit of HTML code there, and I just have a bit at the end where it just goes and takes this string, which I've defined as HTML here, and opens it in Internet Explorer. Yeah, not even Chrome, Safari or anything like that. Internet Explorer, proper old school. But actually what that allowed us to do was set up a number of templates around this. So we could have something where we just set something up in Excel, type in the code of a school you're interested in, give me a marker colour for it, and also a label to have on there. Click the button, you have a map, and it's an interactive map. You can zoom in and out, you can do a load of different things with it. I'd show it here, but the Wi-Fi connection died on that machine just before we started. But the important thing about this is there were a handful of us who understood what was happening with the JavaScript stuff and wrote up the knowledge management on it. But we then created a template that anyone in the organisation could take their data, throw it into it, and generate these maps. So they could be doing the stuff to generate the business interest across the business to then justify more people knowing the JavaScript to develop more complex maps. So you get the snowball effect from that. Similarly, we can do stuff on heat maps, type in the code of a local authority, type in the colour you want it to be, press the button, you've got a dynamic heat map. The people using it didn't need to know anything more than the code of the local authority and the colour, and then it generated through into that. But again, it was a small group of us who knew how to do the JavaScript stuff that was building it up. And most of these things, the stuff I'm showing here, there are tutorials on that Leaflet website that show you how to make the flat map doing that. And then it's just a case of using that little trick I showed around the Visual Basic to put the individual numbers in. Right, final bit here, which is the ironic bit, finding the time to innovate at the point in the presentation where he's running out of time. It doesn't matter that I'm running out of time on this so much in this session, because the M&S session this morning did a really good job about talking about organisational change around this, which is why I've kind of shrunk my time down on this. The key thing I wanted to pick out of all of this is these bits here. Don't assume that everything you start will succeed. A lot of it will fail. These are new techniques. These are things you don't fully understand at the moment. You may well get halfway down the road and find that it isn't working from you. The results it gives don't meet your data, aren't what you need to do with the data set. You may well find that, say, 9 out of 10 of the things you do don't work. But what you'll also probably find is the 1 out of 10 that does work repays you many times over for the 9 that didn't, as long as, when things aren't working out, you stop and move on. And I think this is an absolutely key thing. A good organisation will reward and encourage people who experiment, understand whether the experimentation works or does not work, and then move on based on that. And they will see it as a sign of strength that that happens. Within Google, people are given targets that are impossible for them to meet. They're given targets where they will always fall 20-30% short, because they know that people will always be involved in projects that don't work. And if people succeeded at 100% of the things they were doing, then they either weren't given enough work to do, or weren't doing things that were challenging enough in terms of breaking new ground, because you were giving them a perfect, you were putting them in an environment where everything always works out. But this only works if you don't make this your hobby, that for 8-9 months you're banging your head on the brick wall trying to make this work. Final bit to end on is the knowledge management bit. We managed this by putting together a whole bunch of pages, which we kind of refer to as wiki site, which helped plug a gap we saw, which is data science is not like a neat university course where you do week 1, and once you've learned week 1 you do week 2, and once you've done week 2 you learn week 3. It's a whole messy area where you can go in hundreds of different directions. What we wanted is something built on the knowledge that we had that allowed you very quickly to say, I want to know something more about decision tree learning. Here's a side of A4, maybe a side and a half, that explains what it is, kind of level that I've explained it to you here. And you can read that and go, that might help with that project, or it might not. But within 5 minutes I've got an idea of whether I should be spending more time reading this or not. I'm not groping around the internet trying to look at the Wikipedia page, which is frankly about 20 pages long and written by someone with a PhD thesis in it, which doesn't help you get your head around it quickly. And this is the kind of level of knowledge management I think a lot of people should be going for. Once someone's done it in depth, summarise it at a level that someone who's new to it can understand. And that's me done through there. Was a bit of a whirlwind again, but there were quite a few things I did want to touch on with that. We're pretty much out of time now, so I'm happy to take questions with people in the room here. We've got half an hour till we're back in the main room for the final plenary. I'm also aware it's very warm in here at the moment. So if you want to ask questions for me now while everyone's here, absolutely do ask that. If you want to creep out and kind of towel yourself down, no shame in doing that at all. If you want to come and chat to me afterwards, please do. But thank you very much, and happy to take questions.